this video, we will discuss about maximum number of integers to choose from a range 1. You are given an integer array band and two integers n and max sum. You are choosing some number of integers following the below rules. The chosen integers have to be in the range 1 to n. Each integer can be chosen at most once. The chosen integers should not be in the array band. The sum of the chosen integers should not exceed max sum. Return the maximum number of integers you can choose following the mentioned rules. So what they are saying is that in the input we are given an integer array bands and we are given two numbers n and max sum. Now what we can do is that we can choose integers from 1 to n, right? Now we need to choose integers from 1 to n such that no integer in this should be present inside the band array, and the sum of all the integers that we have chosen should not exceed the max sum, right? So now how many maximum number of elements can we choose? That we need to return as our answer, right? So if we see here, n is 5, so then that means we can choose the numbers 1, 2, 3, 4, 5. Right now, out of these, 1 and 5 are present in the band array. So then that means these cannot be chosen. So we will remove this, right? So we are left with 2, 3, and 4, right? Now we need to maximize these many number of elements such that their sum do not exceed the max sum, right? So if we consider the sum of these three elements, so it will be 2 plus 3, 5 and 5 plus 4, 9, which is exceeding the max sum. Then that means we cannot choose these, right? So one is that we do not take 4. In that case, 2 plus 3, the sum will be 5, which is less than max sum. So then that means two elements we can choose. Other cases that we take 2 and 4. So there the sum will be 6, which is equals to the max sum. So these can also be taken. In this particular case also there are two number of elements. And the other cases where we take 3 and 4. But here we cannot because their sum will be 7, which will exceed the max sum. So in this particular case, the maximum number of elements that we can choose following the constraints is 2. Right? So now, as I said, the numbers that we can choose are 1, 2, 3, 4, 5. Right. Now see, you want to maximize the number of elements that you are choosing, and you also want to be within the limit of max sum, right? So what you will do is that you will try to take the smaller elements first. You will try to choose the small elements first. Why? Because if you will take small elements first, then there are chances that max sum will be exhausting after taking more number of elements. If you would start with greater number first, with the larger number first, then in that case what will happen is that you will exhaust your max sum limit with fewer number of elements only, right? And our goal is to maximize the number of elements that we are choosing, right? That is the reason we will always start with the smaller number first, then we will consider the just next greater number. So first we will consider 1, then 2, then 3, then 4, and so on until we exhaust our limit of max sum, right? Because starting with a greater number will give us less number of chosen elements, right? So now we have understood that first we will take 1, then 2, then 3, then 4, and then 5, right? Now when you are considering a particular element, first you will check whether that number is present in band array or not, right? So if it is present, then that means we should just move to the next element. We will continue to the next element, right? Then if the element is not present in the band array, then we need to check that whether we can choose this element or not. And how you will check that? You will check whether this is exhausting the maximum sum or not, right? So whenever you are considering a particular element, you can subtract it from the max sum. And after subtracting, if the max sum is becoming negative, then that means this particular element cannot be chosen. And if it is not coming as negative, then that means we can choose this. So if in this case, if you see, if we choose 2, it is not present in the band array. So we will subtract it from the max sum. So it will be 6 minus 2, that is 4, which is positive. So then that means 2 can be considered, right? So now you will update your max sum to 4, right? This will become 4. Then next element will come as 3. Now in this 3, you will see again 4 minus 3 will be 1, which is positive. So then that means you can consider 3 also. Now your maximum will become 1. Then you will come here. Then you will do 1 minus 4, which is negative. So then that means 4 cannot be considered. If we will consider 4, then we will exhaust the limit of maximum, right? Now, if choosing 4 is exhausting the max sum, will choosing 5 also exhaust our maximum? Yes, right? Because all the numbers towards the right of 4 will be greater than 4, right? And if 4 itself is making the max sum as negative, then the greater elements will also make the max sum as negative, right? So, whenever at any point in time I have got an element where my max sum is becoming negative, I can for sure say that there is no need for checking the further elements. I can stop here itself, right? So, at this particular point, whatever is the count of elements that I have chosen, I can return it straight away. So, here we had chosen 2 and 3. So we can return 2 as our answer, right? So this is what we are going to do. So see, what we can do is that we can maintain a counter variable which will count the number of elements that we have chosen, right? Then we will run a for loop of num starting from 1 till n. Here n is inclusive because we can choose nth element also, right? So we will run a loop from 1 to n. Now we need to check that whether this number is present in the band array or not. So let us suppose that right now I have some arbitrary function which is telling me whether this number is a band number or not. So let's name it is band, right? So if this number is band, then we will simply continue, right? We cannot do anything with this number. Otherwise, we will check that whether this number is exhausting our max sum or not, right? So if max sum minus num is coming as negative, then that means further elements cannot be taken into consideration and you return the count from here itself. Return the count, right? Otherwise, if it is not coming as negative, then that means we can choose this element. And if we are choosing this element, then first we need to update our max sum. So in this, we will subtract the current number and we will increment our count by 1, right? So this is what we can do. And at the end, we can return our count, right? Simple. So now if we consider the numbers, so our num will go to 1, 2, 3, 4, 5, right? So initially we will take this number. It will check whether this is a band number or not. So yes, it is. So it will continue, right? It will move to the next element. Next element is 2. Is it present in the band array or not? No. So it will come here. Max sum is 6. Current number is 6 minus 2 is not less than 0. So then that means it will come here. From the max sum, we will subtract num. So max sum was 6, now it will become 4. And count was 0, now it will become 1, right? Then we will move to the next element, which is 3. So is it band? No, it is not. Then we will come here. Max sum is 4. 4 minus 3 is less than 0. No. So we will come here. Now max sum will become 1 and count will become 2. Then we'll move to the next element, which is 4. Is it band? No, it is not. So we will come here. 1 minus 4 is less than 0. This condition is true. So we will return count from here itself and the count is 2, right? So this is how we can identify the answer. Now, the only thing left to find out is how to check that whether the number is present in the band array or not, right? So see, one of the possible approach for searching this particular number inside the band array is binary search, right? What you can do is that you can sort the band array. First, you can sort the band array. Now, once you have sorted it, can you apply classic binary search of searching this number inside the sorted band array? Yes, we can. So what you will do, you will take a pointer left, which will be 0 initially, and you will take a pointer right, which will be pointing to the last element in the array. So let us suppose that the number of elements in the band array are m. So right will point to m minus 1, right? And then what you do, you run a loop that while left is less than equals to right, right? While this condition is true, we calculate the mid, right? So mid is equals to left plus right minus left divided by 2. This is how you calculate the mid. And then you check that if inside your band array, if band of mid is equals to the target element that we are looking for, right? If it is equals to the target, which is this num that we will pass into our function. So if they are equal, then you can return a true from here itself, right? That is, we have got the target element in the band array. Otherwise, you will check that if band of mid is greater than target. So if it is greater than target, then that means we should look in the left half. And if we want to look in the left half, so we will update our right to mid minus 1. Otherwise, we need to look in the right half. So in that case, we will update our left to mid plus 1, right? So this will be your loop, and at the end you can return a false, that okay, this particular element was not found in the band array, right? So this approach we can follow. In this particular function is band, what we can do is that we can find out whether the particular element is present in the sorted band array or not, right? So here first you would be sorting the band array, then you would be running a for loop, and then inside this you will be calling this particular function, which will tell you whether the number is present in the band array or not, right? So here if you see, here you are sorting the band array, right? And we are considering its length as m, so it will take m log m time to sort, right? Then here we are running a loop n times, right? Inside this, we are calling the function isBand. Inside this isBand function, we are applying binary search over our sorted band array, right? So this is always going to take log m time, right? What is the time complexity of binary search? Log m, right? So here, the overall time complexity of this particular code will be order of n into log m plus m into log m. This m log m for sorting the band array, and this n log m for this particular loop, right? So we can write it as order of n plus m log m, right? So this will be the time complexity of this particular code, right? Now there is one more approach of finding out whether the number is a band number or not. So instead of performing binary search, what you can do is that you can push all of these numbers into a hash set, right? So when you will push all of these numbers into a hash set, then what will happen is that you can check whether the particular number is present in the set or not in constant time, right? Because lookup operation in the set will take constant time. So in that case, what will happen is you do not have to sort the band array, right? You will just simply add all the elements in the band array inside the set, right? You will run this loop n times. Inside this operation, which was taking log m time, this will take constant time now, because here you would be checking whether num is present in the set or not. And on the basis, you can continue or move to the next operations, right? So in this particular case, what will happen is that first you will be inserting all these elements into the set, right? Which will take order of m time. Then here you would be running a loop n times, and inside this, all of these operations are in constant time, right? So in this particular approach, your time complexity would be order of n plus m, right? But in this particular case, we have taken extra space of storing the elements into the set, right? So let's quickly look at the code of hash set. So first of all, we will create an unordered set, right? It will store integers. Let's name it S. Now inside this, we want to store all the elements of the band vector. So we will write band dot begin, comma, band dot end. So it will store all the elements of the band vector inside it. Then we need a variable count for counting the number of elements that we have chosen. Then we will run a for loop of num starting from 1 till less than equals to n. N is inclusive here, and num plus plus, right? Now inside this, we need to check that whether this particular number is a band number or not. So if s dot count num, then continue, right? This is a band number, continue. Else we will check that if max sum minus num is making it negative, then return the count from here itself, right? Otherwise, from the max num, subtract this num, right? And then increase the count by 1. And at the end, we can simply return our count. So let's quickly run this code. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.